Hello all, this is Jayaratilakshmi from Sri Meenakshi Government Arts College for Women, Meenakshi. Here we are going to see about K-means clustering algorithm. Now start with what is clustering. Clustering is one of the machine language technique. It is used for grouping similar data points together. Similar data points means the data points contain same characteristics or features. The goal is to partition a data set into groups so that the data points in the one cluster to other are not similar to each other, but data points within the same clusters are more similar to each other. It is an unsupervised learning technique. That means it does not require any labeled data for training. Example for labeled data set is in a data set of images containing pictures of dog and cats. Labeled data would include annotations specifying whether each image is a dog or a cat. Similarly, in a data set of emails, labeled data might indicate whether each email is spam or not spam. Next, we are going to see about types of clustering algorithms. There are seven types of clustering: K-means clustering, hierarchical clustering, density-based spatial clustering of applications with noise, mean shift clustering, Gaussian mixtures model, spectral clustering, fuzzy C. Next, we move on to K-means clustering algorithm. It is a unsupervised learning algorithm. It does not contain training phase. Unsupervised learning only contains texting phase, which groups the unlabeled dataset into different clusters. Unlabeled dataset means the dataset does not contain same characteristic data points. K defines the number of predefined clusters. If K equal to 2, there will be a 2 clusters, and for K equal to 3, there will be a 3 clusters, and so on. Basically, it is a centroid based algorithm. Each cluster is associated with a centroid. That means clusters are formed around central points known as centroid. The main aim is to minimize the sum of distance between the data points and their corresponding clusters. Next, we are going to see about properties of clusters. Let's try understanding the simple example. A bank wants to give a credit card offers to its customers. Certainly, they look at the details of each customer and based on their information, decide which offer should be given to which customer. Now, the bank can potentially have millions of customers. Does it make sense to, to look at the details of each customer separately and then make a decision? Certainly not. It is a manual process and will take huge amount of time. One option is to segment its customer into different groups. For instance, the bank can group the customer based on their income. The bank can now make three different strategies or offers, one for each groups. Here, instead of creating different strategies for individual customer, they only have to make three strategies. This will reduce the effort as well as the time. They will categorize the customer as high income, average income, low income. Bank only wants to use the income and the debit to make the segmentation. They collected the customer data and used a scatter plot to visualize it. Here, here the image on the x-axis we have the income of the customer and y-axis represents the amount of debit. That each customer can be segmented into four different clusters. This is how clustering helps to create segments from the data. So let's look at the properties of these customer. First property of K-means clustering algorithm. All the data points in the cluster should be similar to each other. Let me illustrate it using the example. The customer in a particular cluster are not similar to each other, then their requirements must vary. If the bank gives them same offer, they might not like it, and their interest in the bank might reduce. So next we move on to second properties of K-means clustering algorithm. Second properties of K-means clustering algorithm is the data points from different clusters should be different as possible. That means customers in the red and the blue clusters are quite similar to each other. The top 4 points in the red cluster share similar properties to those of the blue cluster's top 2 customers. They have high incomes and high debit values. Here we have clusters from differently. We are looking to case 2. Points in the red cluster completely differ from the customer in the blue cluster. All the customer in the red cluster have high income and high debit, while the customers in the blue cluster have high income and low debit value. Clearly, we have a better cluster of customer in this case. Hence, data points from different clusters should be as different from each other as possible to have more meaningful cluster. The K-mean algorithm uses an iterative approach to find the optimal cluster assignment by minimizing the sum of squared distance between the data points and their assigned cluster centroid. Next, we move on to application of cluster in real world scenarios. It is being used in almost every domain, from banking and the recommendation engines to document clustering and image segmentation. Here we see about document clustering example. This is another common application of clustering. You have a multiple document and you need to cluster similar documents together. Clustering helps us group these documents such that similar documents are in the same cluster. Next, see how to apply K-means clustering algorithm. Choose the number of clusters K. The first step in K-means is to pick the number of clusters. You want to take 3, 4 cluster, 5 cluster as you like. Next, select K random points from the data as centroid. Next, we randomly select the centroid of each cluster. Let's say we want to have 2 clusters, so K is equal to 2 here. We then randomly select the centroid. Here, the red and the green circles represent the centroid for each cluster. Next, assign all the points to the closest cluster centroid. Once we have initialized the centroid, we assign each point to the closest cluster centroid. Here, you can see that the points closer to the red points are assigned to the red cluster, whereas the points closer to the green points are assigned to the green cluster. Next, recompute the centroid of newly formed clusters. Now, once we have assigned all of these points to each cluster, the next step is to compute the centroid of newly formed cluster. Here, the red and green crosses are the new centroid. Next, repeat step 3 and 4. We then repeat step 3 and 4, the steps of computing the centroid and assigning all the points to the cluster based on their distance from the centroid is a single iteration. Then we are seeing two stopping criteria for K-means clustering. There are essential 3 stopping criteria that have been adopted to stop the K-means clustering. The first step is centroid of newly formed cluster do not change. The second step is points remains in the same cluster. If the points remains in the same cluster, then we stop the clustering. Next, the maximum number of iteration is reached. We can stop the algorithm if the centroid of newly formed clusters are not changing, even after multiple iteration. If you are getting the same centroid for all the clusters, we can say that the algorithm is not learning any new pattern and it is trying to stop the training. Another clear sign that we should stop the training process if the points remains in the same cluster even after training the algorithm for multiple iteration. Finally, we stop the training if the maximum number of iteration is reached. Suppose we have set the number of iteration as 10, 100. The process will repeat the process for 100 iteration before skipping. Thank you.
Hope you all enjoyed the theory part of K-means algorithm. Now I am going to demonstrate the practical part of, that means the coding part of K-means algorithm using Python. For this I am using Colab to run our Python code, and I am having a data set namely clustering.csv, and it was a banking data set, and it has nearly 380 data entries and nearly 13 fields. But we are not going to use all these 13 data fields. I am just going to use two fields, namely applicant income and loan amount. And we are going to cluster these data sets into three clusters. We are going to create 3 clusters. First, let me import the important package, namely pandas, numpy, random, and other things. Let me import this, and I am providing the data set in the description box also. You can refer that. So we have successfully imported the libraries. Now let me import the data set, that is clustering.csv, in the Colab. You can add any data set using this symbol here. It will open the file manager window. You can select this and open it, and after opening you can copy the path of file here and you can paste it in the read CSV, so it will read the file. Let me run this, and we are giving here x.head, so it will return a first 5 entries in the CSV file. Let me move on to the next code. Here here we are having k equal to 3, which means we are going to create only 3 clusters. We are assigning k equal to 3, and for centroids we are going to take a random samples, which means we are going to take, here we are having k equal to 3, which means we are going to create only 3 clusters. We are assigning k equal to 3, and for centroids we are going to take a random samples, which means we are going to take a random points from the data set, and we are plotting it in a graph. For plotting, we are using applicant income and loan amount. These 2 attributes only we are taking, and we are setting the color as black. Here C denotes the color, and we are plotting the centroids, which is applicant name with centroids of applicant name and loan amount as red, and we are labeling the X label as annual income and Y label as loan amount in thousands, and we are using the plot.show plt.show to show the plotting. Let me run this. So here we can see the plotting. Here these 3 red points denotes the centroid and the other points of the other attributes. If I run it again, these red points will change its position. As for every run, the red points will be changed, which means the centroid was changed as the centroid was chosen as randomly. So let me run this. So you can see the red point was changed its position, which means the centroid was changed now. So for K means we are going to use the Euclidean distance to find the distance between centroid and the other points. For this, we are taking a difference which was a variable as 1, and I am taking a variable j as assigned as 0, while the difference is not equal to 0, which means difference was more than 0. We are copying the x, which was the data set, into xt and assigning 1i as 1. For here, the first for loop denotes the centroids, and which means the first for loop iterates the centroids, and the inner for loop iterates the all the data points in all other data points in our data set. So in these lines we are calculating the Euclidean distance. The formula of Euclidean distance was x2 minus x1 the whole square plus y2 minus 1 the whole square. So here the row C denotes the x2 and row D denotes the x1. These two asterisks denotes the square. If we put 3 here, it represents cube. So as we want square, we are using a 2 here, and we are finding the square root, and we are taking it in a D, and we are appending it in ED also. So we are calculating, so in this set of codes we are calculating the distance between centroids and other points. Now we need to group the data points towards the centroid, for which the points was closely related to, which means the distance between the centroid and the data point should be lesser. Then only we have more similarities. So we are here we are calculating the minimum distance and the normal distance between each centroid and the other points. If the minimum distance was more than that, we are just swapping it, and we are appending it in the cluster, and we are grouping it in a cluster. And for every iteration we are calculating the difference here, which means we are calculating the centroids, and we are calculating the oldest centroid points with the new centroid points. Actually here we have minus the old centroid points with the new centroid points, so that we can have a clear look that is there any change in data points, which means the data centroid points occurs or not, so that we can easily track that jumping of data points was occurred or not. Let me run this code. And here you can see there is no jumping of data points for the centroids. Let me again run this code and choose the centroid points, choose other centroid points, any other centroid points. So now the centroid was changed, and now let me run this code. So here you can see these was the difference between old centroids and the new centroids. So after these differences, these many iterations, we have got the stopping condition as 0.0, which means the iteration stops when there is no change in centroid, there is no jumping in data points occurs. Now we can visualize these clusters by giving a difference in color. Let me have blue, green and cyan color for as we are having 3 centroids, we are having 3 colors here, and we are plotting these data points, and we are assigning each and every color for this, and we are having the centroids as red, and for a class we are assigning any color from this array, from this list, from this color list. Let me run this. So here you can see we are using these three center points. We are splitting the data points into three clusters, which was one was in green color, one was in light blue, and another was in navy blue color. So this is how we are clustered the data points using K-means algorithm. If you need more clusters, you can change the K value here. As we have given K value as 3, it gives only 3 clusters. If you need more clusters, if you need 4 or 5 clusters, you can give 4 or 5 here. So hope you all enjoyed this video. Thank you for watching.